Welcome to our learning module covering the setting element of our Danfoss pressure and temperature controls. By the end of this session, you will be familiar with the contact functions for control, monitoring, and alarm, as well as the differential switch and neutral zone options. Any pressure or temperature control consists of three basic elements: the sensor element, the switch element, and the setting element. In this module, we will go through the setting element. Danfoss temperature and pressure switches have a set point that can be adjusted by the user. On most switch modules, there is an indicator scale on the switch to aid in this. However, the values on the scale are indicative only. A thermometer or pressure gauge should be used to achieve the most precision. Additionally, on most switches, the differential is also adjustable. A larger differential results in fewer switching cycles and longer life. The graphs on the following pages show how the differential works in rising and falling pressure situations. Let's take a look at the cutoff for rising pressure. When the pressure exceeds the upper set point, contacts 1 and 2 break, and contacts 1 and 4 make. When the pressure falls to the lower set point, the contacts change over to the initial position. Contacts 1 and 4 break, and contacts 1 and 2 make. Let's take a look at the cutoff for falling pressure. When the pressure passes the lower set point, contacts 1 and 2 make, and contacts 1 and 4 break. When the pressure rises to the upper set point, the contacts change over to the initial position. Contacts 1 and 2 break, and contacts 1 and 4 make. The range and differential settings can typically be changed by either turning a knob or using a screwdriver. A differential pressure switch compares two pressures and acts on the difference in pressure. On the following pages, you can see a differential switch application and the contact function for falling pressure. Let's take a look at an alarm application for a dirty filter showing rising differential pressure. Contaminated oil gets into the filter. As the differential pressure rises over the filter, the differential pressure switch gives an alarm. Let's take a look at the cutoff for falling differential pressure. When the pressure passes the lower set point, contacts 1 and 2 make, and contacts 1 and 4 break. When the pressure rises to the upper set point, the contacts change over to the initial position. Contacts 1 and 2 break, and contacts 1 and 4 make. Some switches are capable of a neutral zone. This is when the switch gives no signal until the upper or lower limits are exceeded. On the following pages, you can see an example of a neutral zone application and a graph of the contact function. Let's take a look at an application for monitoring the air pressure level. When compressed air is supplied to the storage tank, the pressure increases. Then compressed air supply and demand are equal. When there is no demand for compressed air, the pressure increases in the storage tank and the air supply must be switched off. Let's take a look at the contact function for a pressure switch and a differential pressure switch with a neutral zone. Within the neutral zone, there is no contact between the connecting points 1 and 2 and 1 and 4. If the differential pressure rises above the neutral zone, contacts 1 and 4 make. If the differential pressure falls by the mechanical differential, which is fixed in the unit, contacts 1 and 4 break. If the differential pressure continues to fall beyond the neutral zone, contacts 1 and 2 make. When the differential pressure rises again by an amount corresponding to the mechanical differential, contacts 1 and 2 break again. Thank you for taking the Pressure and Temperature Control Setting Element module.